Okay, now that I know how to set up a factor labeling problem, calculate molar mass for an atom and a molecule, now we're going to talk about how we use that molar mass in a conversion. So we're going to talk about two new conversions and two new factor labeling procedures today during this video. Okay, the first one is going to be the mole mass relationship. Okay. And this is going to look exactly like we've been doing, okay, except now, instead of molecules or atoms and using Avogadro's number, we need to use the periodic table to find grams. Okay, now this is my favorite part of the mole unit because from here on out, every time I say grams, the first person in class that says periodic table will get an Einstein, okay? And what I'm doing is I'm conditioning you to realize that every time you hear the word grams, you think periodic table, okay? Because that's where you need to look to figure out your mass conversion in your factor labeling problem, okay? So let's look at what this may look like, or what a problem will come across that you look like, or that it looks like, okay? So it says, what is the mass of 9.45 moles of aluminum oxide? Uh-oh, naming's back. I told you naming wasn't going to go away, okay? So the first thing that I have to do in this problem is create the formula so I can then calculate the mass, okay? So if I remember, aluminum, so is a metal, oxide is a nonmetal. Therefore, to figure out the formula, I write down their charges, and if they don't cancel, I crisscross them, okay? So I'm going to go aluminum plus 3, oxygen is minus 2, okay? Charges don't cancel, therefore I'm going to crisscross them. So this will become Al2O3. Okay? So let's just real quickly figure out the molar mass. Sorry about that. Really quickly, let's figure out the molar mass for aluminum oxide before I set up this conversion. Okay. So what I'm going to do is I'm going to say aluminum is 26.98. I have 2 of them, so I'm going to say times 2 plus oxygen is 16, so I'm doing 16 times 3. And this molar mass is going to be 101.96 grams per 1 mole. Okay, now let's solve this problem. It says, what is the mass? Okay, so question mark, what am I looking for? So it's question mark grams, specifically of Al2O3, okay, is equal to, okay, question mark grams, aluminum oxide is equal to the number I'm given, which is 9.45 moles of aluminum oxide, okay? So I'm moving from moles to grams by just using the conversion factor that I developed yesterday, which is molar mass, okay? So I'm just going to set up my conversion. So what unit am I canceling? I'm canceling moles, so it's going to go on the bottom of the conversion. So moles of aluminum oxide goes in the bottom. What do I want? Grams. Do I have a direct relationship? Yes. Why? Because of this awesome thing, the periodic table, okay? So I can put grams of aluminum oxide in the top, okay? And for every 1 mole of aluminum oxide, how much does it weigh? Well, I already calculated that, and it weighs 101.96 grams, okay? So follow the units. Moles cancels. Am I left with the unit that I want? The answer is yes, therefore I can now plug this into my calculator. So I'm going to say 9.45 times 101.96 divided by 1, which is going to be the same answer. So the amount of grams that I have in this compound is 964 grams of aluminum oxide. Okay, and that's my final answer. Okay, why do I care to convert moles into grams? Well, let me ask you this question. Do I have a scale in my lab that measures moles? The answer is no. I only have a scale that measures grams. So grams is way more valuable to me because I actually have a tool that I can use to measure this amount. Okay? All right, let's do another one. What is the mass of 0.76 moles of carbon disulfide? Okay? Non-metal, non-metal, so I just write it as it is. So it's carbon disulfide, which is CS2. Okay, so let's calculate this. Carbon is 12.01. I have 2 sulfurs, and they weigh 32.07. So this mass, or molar mass, is going to be 76.15 grams per mole. Okay? All right, so here we go. It says, what is the mass? So question mark, what am I looking for? Question mark, grams of carbon disulfide is equal to, what am I given? 0.76 moles of carbon disulfide. Now I'm going to set the conversion up. What am I canceling? Moles. So moles is going to go in the bottom. What do I want? Grams. So grams goes in the top. And for every 1 mole, how much will carbon disulfide weigh? Carbon disulfide will weigh 76.15 grams. And so moles cancels. I'm left with this unit that I want, that was my original question mark. Now let's plug this into our calculator. So I'm going to say 0.76 times 76.15 divided by 1. So if I'm watching sig figs, I should have 2 sig figs. So my answer here is going to be 58 grams of carbon disulfide. Okay, and that makes sense, right? Because if only 1 mole is equivalent to how much it weighs on this guy, I would expect my mass to be larger than my moles, okay? I'm going to skip number 3. This is the one that I'm going to check for homework. I'm going to look at number 4, okay? Number 4 says, how many moles? Okay, now this time I'm not doing grams, question mark grams, I'm doing question mark moles, okay? So this time I'm doing moles of calcium phosphate, okay? Here's a polyatomic, here's a metal. Calcium is Ca plus 2. Phosphate is PO4 minus 3. Charges don't cancel, therefore my formula will be Ca3, parenthesis, PO4, 2. Okay, now this guy's big, so let's calculate calcium phosphate. So calcium is 40.08. There's 3 of them, times 3. Plus, now you have to remember, this is going to distribute. So I have plus 2 times phosphorus, which is 30.97, plus 8 times 16. So this weight is going to be 310.18, and it's grams per mole. Okay, here we go. Question is stating, how many moles? So I'm going to say, question mark, moles of calcium phosphate. Don't get lazy. Write everything out, please. Okay? Moles of calcium phosphate is equal to 0.084 grams of calcium phosphate. Okay? This time, I'm getting rid of grams, so grams goes in the bottom. So grams of calcium phosphate goes in the bottom, and I want moles of calcium phosphate, and that goes in the top. Okay, let's look here. 310.18 gram per 1 mole. So 1 is going to go with mole, and the 310.18 is going to go with the grams. So then in my calculator, I'm going to go 0.084 times 1, which is just itself, divided by 310.18. Therefore, the amount of moles present, I need two sig figs, is 2.7 times 10 to the negative 4 moles calcium. Sorry, calcium. I messed these up. This is 2, this is 3, this is 3, this is 2.
Attention students.
Okay, sorry, the announcements keep coming on. So you'll notice I messed up the 2 and the 3. So the final answer here should be 2.7 times 10 to the negative 4 moles of calcium phosphate. Okay, one more conversion. This conversion's a lot easier. This is another defined conversion. I don't have to look on the periodic table for this one. Okay, it's the mole volume relationship. So if I'm talking about a gas that is at standard temperature and pressure, the volume of 1 mole of any gas is going to be 22.4 liters. So my conversion that I'm developing is 1 mole of gas is going to be equivalent to 2.4 liters. Okay, so let's do a couple of these problems. So if I look at this one, it says how many liters are in 0.375 moles of oxygen gas. So oxygen gas, it's a diatomic, so it'll be O2. Okay, so my question mark here is liters, and that's equal to 0.375 moles of O2. Okay, now I can do this conversion. What am I canceling? Moles of O2. What do I want? Liters of O2. Okay, what number lines up with mole? As always, 1. What number lines up with liters? 22.4 as always. If I plug this into my calculator, I should get 0.375 times 22.4. I should get 8.4, but we need one more sig fig, so I'm going to add a 0. And this is liters of O2 gas, okay? Go ahead and try number 2. We'll go over number 2 in class, but I just wanted you to develop that relationship between liters and gas. Thank you.